Okay, so in this video I want to discuss how to make a line follower. Now this bit of a line follower that I've put together here brings into play some of the information discussed in the previous videos. Now in the last video we discussed how to read two LDRs, as you can see here, using your microbit and Kitronik all-in-one breakout board. Now the wiring that you can see here on the front of it is the exact same wiring used in that video, where we have our two LDRs attached directly back up to our microbit and breakout board with their 3 volts ground as well as their individual pins reading the values. The only difference is that we've mounted the two LDRs on the base plate, as you can see here, through the board itself, and we've changed out this battery for a smaller 9-volt battery. What we've also added into the back section here, using our 2 terminal motor blocks, even though we have 4, we just use 2 of them, 1 and 2. We've attached 2 DC motors, these yellow geared box motors, mounted with these 3D printed brackets. Now the reason we've added just 2 motors, because that is the minimum you need just to maneuver your robot left and right, just to ensure that the robot itself stays along the line or the track itself. Now the track that we will be using for this robot will be an all white track with a black line on it. I find that to be, I suppose, the most consistent way to run a line follower. You can do it the opposite way around, and you can configure this that it runs, that the LDRs run on either side of the black line or either side of the white line on the black, or the other way around, where the LDRs run on the black line or on the white line itself. Now for this particular this line follower, we're going to be using a white track and a black line, similar to what's displayed here, but this obviously line will continue on. We have placed our LDRs in a location where it can pick up the values from the white and be able to identify then when it crosses over to the black that it can then write itself, and it does that as it follows itself all the ways around the track itself. Now the main thing about completing a line follower is not putting together the different components. The components itself are quite basic. You can see how quickly we could put together these two LDRs in conjunction with this microbit and breakout board, and how easy there it is just to connect up 2 separate motors with small mounting brackets. The complicated part of this is really when it comes down to the coding itself. There's 2 bits of code we're going to use. We're going to have 1 piece of code which we're going to use first, just to identify the different light values on the track we're going to be using. So we're going to obviously have to manufacture a large track, which this robot can run around. And on that track we are going to want to know the values that we're going to be reading from these LDRs on white, and the values that we're getting from these LDRs on black, so that we can tell, look, we got this value, it's on black, it needs to write itself by, let's say, having this wheel move forward and the other one stay still. And then when they're both on white, they both go forward until they hit black again, and then it maneuvers to stay on that line itself. But to do that, we obviously need to get our light values. And the one thing about a large board is that depending on what room you are, if there's light coming in from a window, that there might be shadows like you can see here underneath my hand in comparison to over here where you can't see any shadow. We're going to be getting different light values, and just to account for that, we're going to need to take those light values from the location that that board is in and ensure that there's no imperfections. If there's large imperfections on the black or large imperfections on the white, which might confuse the robot and think that it is on black or white when it is in fact not on that surface, we need to account for all that. So to do that, we obviously need our 2 sections of code. One is the actual code the robot travels through, and then one is just to identify our different values. Now to keep track of all the values we're going to be getting from our first section of code, we're going to use a little calibration sheet like this. This one is actually available on the website itself, where you can get the student or whoever's making the line file to identify their name, and then secondly, identify which, I suppose, pins they're using for each of the sensors. So we have LDR1 here, left side, and LDR2 here right side, and then we pin and then a space pin in the pin. So for instance, our left side here, so the LDR1, let's call this LDR1, it has this white wire going back to pin 0. So we can say that LDR1 left side pin 0, and then we can say LDR2 right side pin 1, because I know this blue wire from the right hand side is going back to pin 1. Then after that, we move our robot around to different locations on the board, reading the value from our 5x5 matrix and writing in the values that we get here on black and white for each of the individual pins. When we've that done, we can identify a middle value, which we can say if we are lower than this value, so if sensor 1 is less than this value, it's on black. So then we know that it runs through a separate code where this writes itself. Now, if that seems a bit confusing, don't worry about it. We'll be running through this whole process of putting together the code as well as the calibration. So what we'll do now is we'll just jump over and talk about putting together that bit of calibration code.
Okay, so now that we've moved across to our microbit coding application, we can start to put together the bit of code that we need to start calibrating our line follower so that we can identify different values that we're getting on different points on black and on white at different locations around the board where the light values might vary a small bit. And to do that, we actually can use the same code as we used previously in our the last video where we were reading the light value and that was coming off the two separate LDRs. So functionally that will work perfect. So what we'll be doing again is we'll be using button A to read one of the sensors and B to read the other sensor and getting that displayed up here in that 5x5 matrix on the microbit itself, so we don't have to use any external applications to read that value. So we'll start off with our input. We'll go into inputs here. We'll go on button A pressed, and then what we need is basics. We need to show a number. And instead of just show a number here, what we want to do is show the number on a pin. So we can click down this advanced button. We can go to our pins. And very important, we're going for analog read, not digital, because the signal we're getting back off the LDR itself is going to be an analog one. And we can say pin 1. Okay, so that's one of our LDRs. Now this itself is sufficient, but what we like to do is add in a basics and put in a pause. You can see here, and make that 1 second, which is 1000 milliseconds. The reason we add that in there is just to give the sensor a chance to, I suppose, identify the value that it's getting and display it up in that 5x5 matrix. I find that you get more consistent value if you add in this pause. Now we want this to happen also on button press B, so we'll just duplicate all of this code, bring it over here, and change this to B, and change the analog read pin O, okay, or 0. So now on button press A, you get the value that's coming back from pin 1, and button press B, you get the value coming back from button press 0. And that's all going to be displayed up here on the 5x5 matrix. That's what the show a number block does. So now what we'll do is we'll jump back and we'll start testing our values at different points on white and black, and start writing down our values so we can identify a value that we can say definitely below this value we are going to be on black, so it needs to go through this maneuver. After we have that value got for each of the sensors, we can then apply that to our second round of code.
Okay, so now that we have put together the calibration code, next is just to upload it to the microbit itself and run through the calibration process where you identify the values that you get on black and white. Now, one thing I failed to mention previously is you can see that I'm going to be doing this for each sensor. If for whatever reason you only want to do this with one sensor and not do it with both, you'll find that the values actually vary between sensors. Even if you're using the exact same sensor and the same setup, you tend to get different light values on each of the sensors. So it's best to run through the process twice, so once with one sensor and once with the second sensor, and then have two separate values, and that way you'll find that the line follower will work better than if you use the one value for both sensors. it might work, but again, there might be a level of error there that will cause your robot to get confused a small bit. Now, to represent the board, we're just going to be using this sheet here, where I just have a black square and a white section. The white will represent the white of the board, and the black will represent that line that the robot will be following on the board. If you're doing this on your own board, you will need to test in different locations. Because my black square is this size, I'm going to be using different sections of this black square. But if you have a large board, you know, that's maybe a meter by a meter, you're going to have to go to various spots to get these different values on black and white, just to ensure that there's different light values are all taken into consideration. So to start things off, I'm just going to turn on the power. I already have the code loaded up to it. I am going to start off by pressing button A, which will bring up pin 1, which I've pin 1 written in here. And we're going to start, I suppose, reading those light values that we're getting. So I'm just going to move it onto black. And this is going to be our left side, so over here. I always read the robot as if I'm standing from this side, so this is left and this is right. Leave left there, press A, read the value that we get. We get 136. So I'm going to write that in, 136. Just going to read that again, see if it's consistent value, 141. So 141. Move it a small bit to somewhere else in the black. Read it again. 150. 150. Move it somewhere else. 162. And maybe up to this top corner where it's kind of a lighter part of the black. 177. And one more value for 6. 138. So you can see there, they're all different numbers, but they're closely packed to some extent. You'll see now how different the values are when we go to white. We're getting 328. So 328, you can see there's a big jump. Move it over here. 264. Big difference between the first value and the second value there, just from the different section. 281. 281. Move further down here. 277. 246. And one more value. Let's go here. 274. Okay, so now that we got a variety of values on white and black for pin 1, we'll start moving over to pin O. And we'll do that by pressing B. We'll start with black, ensuring that our pin here on the right hand side now is on black. 3, 1, 3. 3. Try it again. 2, 4, 4. Move it somewhere else. 3, 0, 4. Somewhere else in the black again. 2, 4, 3. A bit further up here again. 2, 3, 2. And last spot. 2, 1, 5. Okay, so you can see straight off the bat, for black value for our left sensor and black values for our right sensor, there's quite a difference between them. So if we were using the value just identifying this sensor to write our code, would obviously have some issues. So now we'll do this for the white. 4, 8, 7. The main thing that we can see here is there's a good difference between white and black for each of the sensors. That will help us with our coding. 470, 493, 576. See, sometimes they might spike a bit higher. 522, and one more. 534. Okay, so the values that we're getting there's quite a variety between the two, which is handy. But the main thing we need to know is what value can we safely say it needs to be below to say it's on black. So our highest number here that we got in black is something we need to look for first of all. So 177, I think that's the highest we have here. And the lowest we have over here is 246. So what I'm going to say is if it is less than 200, we can nearly safely say we're on black for this sensor. So if we look at our highest value this time over here, it's going to be 313, and our lowest value on white is going to be 470. So we say if it's less than 350, we can safely say that we're going to be on black. So these two numbers here, so less than 200 and less than 350 are the numbers we're going to be using. Now I'll even go a small bit further to say less than or equal to by putting a line below this. We can safely say they're on black. So if we take this information, now we can write our piece of code to actually get the robot to follow this line on the board, on the location it's in, with the consistent light value that is displayed on that board.
Okay, so now that we've got our values that we know that they need to be under to identify it's on black. So for instance, our LDR1, we said that it needs to be less than or equal to 200. And for our sensor 2, which is pin 0, it needs to be less than or equal to 350. So now that we have that information, we can start writing our bit of code that we need for our robot to actually follow the line itself. Now, to do this, we're going to need some additional blocks, mainly because we're using the motor blocks that are integrated into that Kitronik all-in-one breakout board. And we need this block below here where it says robotics and has these subsections, servos, motors, and settings. You will not have those by default within this application. What you need to do is you need to click on Advanced. You need to scroll the ways down to Extensions, and you need to type in all-in-one. What will come up then is this Kitronik Robotics Board, the all-in-one, the robotics breakout board that we're using. You'll click on that, and it'll add these additional blocks as robotics, servos, motors, and settings in here, and this will come in handy. After that, we're going to need to go into our basics. We need to get our forever block. We'll also need our logic block. So this is basically to help us identify what to do in certain situations. We're going to need to click on the plus twice. So we have these three different sections. So we basically have this: if we're on black on this sensor, we run through this. If we're black on the other sensor, we run through this. And if both of those aren't true, we just do what's below here in this bottom section. We'll need our motor blocks. So we'll go to motor. We'll go for this block here, so motor 1 on direction forward, speed 0. And we're going to duplicate that to each of these individual sections. So we'll have 6 motor blocks altogether, like so. We're also going to need to identify the motor blocks that we're using. So you'll notice on that board there's 4 different terminals, and they'll actually indicate on the board itself which one's 1, 2, 3, and 4. If you remember back, we've actually only used motor block 1 and 2 to connect up the motors to the motor block, so we'll use them. I'll leave this first one as 1. I'll change the second one to 2. I'll do that for the rest of them as well. So change this one to 2 and change this one to 2. Okay. Now these are going to be, so let's say this first section above here, This is going to be the section where we basically tell it what to do if it's on black for one of the sensors, and the same thing below here. If it's on the other sensor, it'll run through this. But this very last one is what happens if it's not on black. So if we're just on white. So what we'll do for this is we'll have motor 1 and motor 2, both going forward at a speed, a slow speed, so we'll say 20% of the power that can be sent to it. And now we'll go back up and basically write in what has to be the case for us to run through each of these individual bits of code in each of these sections. So we'll go for, first of all, logic again. We'll go for a comparison block, like so. Drop that in. We'll go for our pin block again. We'll go for analog read pin. Drop that in. We'll leave the first one as pin 0. And then we'll change this to less than or equal to, like you saw previously. And we'll write in the value that we got for pin O. So if I remember correctly, that was 350. So it has to be less than or equal to 350. And that basically means I'm black. And then it runs through this piece of code. What we want to happen is we want to say that the second motor, we'll just put in reverse, even though we won't get it to run at all. We'll just leave it at 0. And we'll get motor 1 to move forward at 20% power. So basically what will happen there is that one of the motors will run and the other one won't, and that will correct it. It will pull itself back over the line again. Now, if you find that it's actually pulling itself off when that happens, you might have to reverse this, where you said this should be motor 1 or this should be motor 2. If in fact your motor is running backwards when it says forward here, all you have to do is change the black and white wire at the terminal block going into your breakout board. We'll do this exact same thing again below here, but we'll swap it around, that instead of motor 1 running forward, motor 2 will run forward and motor 1 won't run. So motor 2 this time will go 20% and motor 1 won't run at all. We'll duplicate this section above here and drop that in, but again we'll change our analog read pin from pin O to pin 1, and our value will also be different, because remember we've got different values for when it's on black on pin 1, and the value we use here is 200. So what will happen is every time it will keep running through this. It will first of all look if analog pin O is less than 350, so if it's on black, if so, it'll run through this. If not, it will go down to this one. It'll identify if the other pin is on black, and if so, it'll run through this, and if not, it will drop down to this one. So at default, it's just going to keep going forward till it gets on black and writes itself. Now, if there's any issues, if it keeps, for instance, thinking it's on black when it's not in black, you might need to go through the calibration process again and change these values up here. Or else you might need to change the direction or speed that the robot's going at. You'll find if you, let's say, go 100% power for each of these ones that I have a percentage power going to it, it might be going too fast along the board, and the robot won't have enough time to read and adjust for the changes. I find going at a nice slow speed like 20% or 10% is quite effective. So it gives plenty time for the robot to identify it's on black, to fix itself, and also identify then if the opposite side goes on black and to fix itself for that.
Now, I just want to add this small bit of a section here first of all, before I show you the robot running along the ring. The reason I want to show you this bit of a demonstration is just talk you through this code and how it actually works. So this is a logic block that we have here. You can see if, else if, or else. There's 3 separate sections here. So you have the first section, we'll just call this section 1, section 2, and section 3. What is happening is that section 1 runs if this piece here is true. Section 2 runs if this is true and that is not true. And if neither of these are true, then this section runs below here. So basically, for the first section, if analog pin O, which is our right-hand side LDR here, is less than or equal to 350, that means it's on black. So if this is true, more than likely our robot is in a situation like this, where this right-hand LDR is over the black. So then it needs to run through this section below here till this isn't true or this isn't true. So what will happen is motor 1 on direction forward, speed 20. Okay, so our motor 1 is this one over here because it's going back to our number 1 terminal. And our motor 2 on direction reverse, speed 0. So motor 2, which is this one, which is the one over here, so this is the block, over to this one, will run at 0, so it won't move at all. So what will end up happening is this second motor will run and the other one won't till it rights itself, and that will be back on white on both sides of the black line. Then what will happen, it will run through this again, it will identify that this is no longer true, this is no longer true, and it will just go for motor 1 and 2 will go at a speed of 20%. So 20% is the power coming from the battery itself. Now, if this overextends and this keeps going for whatever reason, or if a turn comes up and then this LDR is on black, what will end up happening is that it will read this, it will say that this is not true because our LDR on the right hand side is on white, so this is no longer true. But our left LDR, so analog read pin 1, which is our left one over here, is now reading less than or equal to 200, and then it must run through this piece of code where motor 1 this time doesn't go anywhere and motor 2 goes at 20%. So what will end up happening is that this will keep going till it's both white. And that will just keep running through that, just ensuring that it stays on the white here or the black. The only thing that really can go wrong here is that both sensors for some reason can be on black. So if it comes to a turn and for whatever reason both of them are on black like so, that can confuse the code. You can work that in here if you want to extend this. As well as that, you might have your speeds too high. So you might have the speed for white and white too high here. And what will end up happening, it will come to a turn. Before the robot has a chance to recognize that it's on black, it will already have passed that and be back on white, or it won't have enough time to correct itself so that it has positioned itself. That's why you can see here I'm using 20% for each of the individual blocks. If you have a higher voltage supply, you might need to lower this, or if you have a smaller power supply, you might need to higher this. You'll notice that if you drop it below 10%, the motors will actually stop turning because it won't actually have enough power to run these motors. Now, hopefully you found this additional video after making the code beneficial understanding of how this runs and how it works in relation to the microbit itself.